So this question, we see a graph, so we will apply our analysis, our Oizerga analysis. So again, it looks like we're in a quadrant 1 situation. Force in normal units. X-axis is time in normal units. So any questions about force and time, we will just read the answers off the graph. The slope is delta F over delta T, which is the rate of change in force. And the area is F delta T, which is the impulse and happens to be equal to the change in momentum of the body. Now, if we squint at this graph, kind of like fuzz our eyes and look for the main idea, it looks like maybe this thing is kind of constant here, like during this segment. And maybe, or constant slope, maybe this one has a constant value through that segment. And maybe this one has a constant slope through that segment. So there's variability in the data, but it looks a little bit like that. So we might say there's this period 0 to 2 seconds, and 2 to 4, and then 4 to 6. All right, so now let's read the question, see what's going on. Net horizontal force acting on an object in a straight line, horizontal frictionless track. So we have object moving, and that's the force. So what is the magnitude of the change in momentum of the object from 0 to 4 seconds? So now we are looking at this, up to 4 seconds. Now we want the change in momentum. Well, that's easy. That's the area. So the area of this green triangle is 1/2 base times height. The base is 2 and the height is 10, so we have 10. Then we have our blue area, which has dimensions of 2 by 10, so that's 20. So it looks like the change in momentum given by the area is 30, and lo and behold, that's one of our choices. And you can clearly see that this 20 choice is simply the area of the blue, so that's out. And 40 is definitely more. And of course, it certainly can be determined. So we're left with 30.